talking again about my water bath, and here you see what happens. That's more or less the interesting thing. The element, the heat, the AC187 transistor cools down, and now it starts to switch the Schmidt trigger on again. And that's what's happening here. That's of course always interesting to see. And on a certain moment, when the water bath is hot enough, the whole switching process stops. Want to refer to my earlier video, there is the schematic of this circuit. And you can see also that there's a kind of time delay here, because the temperature sensor heats up. That means that the Schmidt trigger acts in another way, and on a certain moment it will stop heating the water bath. And you see the sparks perhaps in the relay. That was kind of problem. I soldered capacitors parallel to the relay, and you can see that in the earlier schematic. So now the whole circuit is stopped due to the fact that the sensor, the AC187 germanium transistor, got so hot that it could no longer say drive the circuit again. But very important, of course, always is what's the temperature. This is the temperature inside the water bath via this sensor here, this one. And of course, much more important is what is the temperature inside all these flasks. And you see it. And of course, this is an outdoor thermometer. That's of course not, say, very precise, but it's now on, say, 37 degrees, I think. 35 degrees, 36 degrees, could be. But you can surely set, say, giving the heater element a better heat push by turning this potentiometer here. Let's try. Let's see what happens. It's all around 38 degrees. That's the aim of the whole circuit. It is made for photographic purposes, and perhaps interesting to show when the AC187 heats up, the voltage parallel to it goes down anyway. Say, let's try to drive that heat somewhat up. Somewhat. Let's see if it works. Yes, it works. You can hear the hum of the heating element here. And you can also see the LED light up. So it means that with this potentiometer you can set it to another part of heating, say to a higher part, and you can see here clearly that the voltage drops up and down. That has everything to do, of course, because the voltage is not stabilized, and that's good in this case. So here it all happens again. You can see the 1000 watt heater heating up the water bath again, and of course the temperature will go up. And this is, like I earlier told, an outdoor thermometer that's not very precise, but like I earlier told, this is a very, very precise thermometer that you can use for this purpose. So let's see what happens. I hope the temperature inside the flask will go to 38 degrees. That's of course the aim of all this, what I've tested and made, etc., etc. So let's wait and see. On a certain moment the heater will switch off, and this is of course not very interesting to see, but anyway also interesting to see that the time during which the switching moment acts changes when the say the AC187 transistor gets more and more hot. It slows down, and on a certain moment of course it will stop. Let's wait and see. And of course you can burn a relay due to all the sparks. At the moment there are no capacitors parallel to the relay contact, so they spark and spark and spark. Anyway, what does this all mean? Say, let's leave it as it is. Watch and see. So now the AC 187 transistor is so hot that the voltage has dropped down to a very, very low value. And that means that the heater is switched off. And after, say, an hour or so, or half an hour, the whole circuit will cool down, and of course we must see now that the heat inside the flask, where the aim was that it had to be on 38 degrees, so perhaps it's visible now. This outdoor thermometer is not very precise, but anyway you can see that it is in the order of 37 degrees Celsius, and that means that the water inside this bath is on approximately 33 degrees Celsius. So thanks for watching. That was all, and it's in my opinion also the final video where I have told how this all worked. The schematic again, perhaps. It's now on my table. Anyway, want to show it again for the second time. I made a thumbnail on YouTube that you could see that schematic, and here it is again. In fact, it's simple, though there are a lot of parameters. Voltage supply, biasing of the first transistor here. This is not biased, by the way. That is the temperature sensitive AC 187, but this is biasing here, is biased here, and also this one here, etc. So go to, when you want to know more, go to my earlier video. So this is a vlog, and when everything is okay, perhaps I will make a new video. Anyway, but at the moment I think this works quite good. Good enough to do, say, photographic experiments, say developing diafilms. And in the past, in the 1970s, I also developed black and white diafilms, small films, double 8 films. That's of course completely obsolete now. It doesn't exist any longer, but I developed them via, say, the reverse development process. And when you know a little bit about photograph technologies, you will surely know what I mean. Thanks for watching. The circuit again. And here we see again, temperature has gone up to approximately 38 degrees. So anyway, thanks for watching.